Okay, we're going to talk about the addition rule of probability. So this is the or word. So when we see the word or in math, that means add. So we're going to use that in this context of probability. And I want to point this out. This is one event happening. Okay, we're going to be using this if there's only one event. So the probability I do this one thing. So there's two different scenarios that we have to be aware of and think about. We have to think about when they are mutually exclusive, meaning event A and event B have no overlap, meaning they can't occur at the same time. Or we have event A and event B with overlap. So that's the overlap. And we're going to have to think about, when you start the problem, think about, is there overlap? Is there a place where it can be both of those things? This will start to make sense when we start working through an example. So my formula or my addition rule for no overlap is to find the probability of A or B is just the probability of A plus the probability of B. If there is overlap, my formula for probability of A or B is going to be the probability of A plus the probability of B, but then I have to subtract out the probability of A and B. So I have to subtract out the part where they overlap. So that's why it's important, which you actually can use that same formula in both cases. You can still subtract out the part where they're A and B, but it'll just be 0 because there is no part of overlap. So if you want to just memorize one formula, it would be this, but you can just practically think through these. So let's do some examples. All right, a pet store has 25 pets, so that's my total. There are 16 dogs, 9 cats. Of the dogs, 13 are puppies and 6 are kittens. So a pet is chosen at random. So that a pet means one event. So we can use the addition rule. So we're going to find the following probabilities. So the big thing I need to think about before I start is, can there be overlap? So can a dog also be a cat? Well, no. Now, a puppy can also be a dog, but we can't make a table where we have cats and dogs in the same. We can't be a dog and a cat at the same time. So this is going to be the addition rule of mutually exclusive, meaning that they cannot happen at the same time. Dogs and cats can, one thing cannot be a dog and a cat at the same time. So now we just go through and we're going to do some basic probability and some addition rule. So the probability of a dog. So we're going to write that as probability of a dog. It's just one event. There's no or in there. So it's simply 16 out of the 25 pets. So I'm going to type that into my calculator to be sure I also know how to give it as a decimal. Either way is acceptable. So 16 out of 25 is the most reduced form of the fraction, and it reduces to 0.64. So either of those are acceptable answers. All right, so the probability of a cat. So that is probability of a cat is going to be 9 out of the 25. That is its most reduced form. So 9 divided by 25 is going to be 0.36. So there's a 36% chance that one of the animals is a cat. All right, a puppy. So probability of a puppy is going to be 13 out of the 25. That is in its most reduced form. And that's going to be 0.52. So either of those are acceptable answers. And lastly, a kitten. There are 6. So the probability of a kitten is 6 out of 25. And there is no overlap on that. So I type it into my calculator and I get 0.24. So those are just basic probabilities. So now we're going to look at a problem that is an OR, and we're going to use that addition the addition property rule. So we're looking for the probability of a puppy or a kitten. So or means add, but I have to think about is can there be overlap? So can I choose something that is both a puppy and a kitten? No, I cannot. So this is that scenario where they are going to be mutually exclusive, meaning there's no overlap. So I don't need to subtract out the overlap. I don't count it twice. So it's simply going to be, so the probability of a puppy or a kitten is just going to be simply the probability of a puppy plus the probability of a kitten. So the probability of a puppy is 13 out of 25 plus the probability of a kitten is 6 out of 25. So 13 plus 6 is 19 out of 25, and that cannot be reduced, but I can write it in its decimal form, which is 0.76. So either one of those is acceptable. All right, in this problem, a pizza shop has two sizes of pizza. They have a large and they have a small. Okay, I've got two options there. On a certain day, a pizza shop made 59 plain pizzas and 72 pizzas with toppings. Of the 59 plain pizzas, 19 were small, and of the 72 pizzas with toppings, 42 were large. A pizza is chosen at random, so that means we're talking about one event. I'm just picking one pizza. Find the following probabilities. Okay, so there's a lot happening, and the best way to handle these is with a table. And the reason we want to do a table on this one, and we did it before, is I need to ask myself, is there overlap? So I've got large and small, and I've got plain and toppings. So can I have a large and small pizza at the same time? No. Can I have a large and toppings pizza? Yes, I can. So I've got to make a table to organize this. So I'm just going to come down here, and I'm going to make a 3x3 table. So I have large and small, and I've got topping. Oh, I'm going to do plain first. I've got plain, and I've got toppings. And then I'm just going to put the totals here. Okay, so let's start filling in this table. So I know that there were 59 plain pizzas made. So I'm going to come over here, and there were a total of 59 plain pizzas and a total of 72 pizzas with toppings. All right, of the 59 plain, 19 were small. So I'm going to come, of these 59, 19 were small. And of the 72 pizzas with toppings, 42 were large. So that's all the information they give me, but that's all the information I need to fill in the rest of this table. So I know that I'm going to start with just the total. So the total pizzas made, if there were 59 and 72 plain and toppings, I just add those together. So 59 plus 72, I had 131 total pizzas made. All right, so if there were 59 plain and 19 of them were small, then 59 minus 19 tells me that there were 40 larges. So I just did 59 minus 19. All right, if there were 72 pizzas with toppings and 42 were large, 72 minus 42 is going to give me 30. So now I can get my other totals. So how many total small pizzas? It's going to be 30 plus 19, so 49. And 40 plus 42 gives me a total of 82 large pizzas made. Okay, so once I've made my table and I can see where everything falls, I can start answering questions. So the first question is asking me solely about being large. So there's only one thing happening. There's no or. So I'm just doing a basic probability. So the probability of being large. I don't care if it has toppings or not. So I'm going to come down to this total. So it's going to be 82 out of the 131 pizzas that were made. So 82 divided by 131 gives me 0.62595. So that's going to be 0.6260. And 82 out of 131 is my most reduced form of the fraction. So go ahead and pause the video and see if you can find the probability of small with toppings, plain, and see how you do. Alright, so hopefully you were able to see that there were 49 out of the 131 that were small, 72 out of the 131 that had toppings, and 59 out of the 131 that were plain. So this next one is going to ask a large plain pizza. So it doesn't say large or plain, it's just asking specifically for a large plain pizza. So that's going to be this 40 right here is going to represent the large plain pizzas. So this one is going to be the probability of being large and plain together at the same time is going to be 40 out of 131, which is 0.3053. All right, so go ahead and pause the video, and I'd like you to try F on your own, small with toppings. All right, so hopefully you got 30 out of 131, which is 0.2290. All right, so G is asking plain or small or plain. So here we have two things happening. We want to know the probability of picking a small or a plain. So I have to think to myself, is there overlap? Could I have a small plain pizza? Which, yes, I can. So there is overlap. So I'm going to have to use the addition rule that takes into account that. So I'm going to break this into the probability of small, or means add, so the probability of plain. But then I have to subtract out the probability of being small and plain. All right? So now the probability of small is 49 out of 131. The probability of plain is this 59 out of 131. But what I've done is I've counted these small plain pizzas twice. So I have to subtract out the fact that I counted them twice. Because if you think about it, I counted them when I calculated 49 small pizzas. That 49 was made up of the small plain pizzas plus the small topping pizzas. But then I also calculated this 19 also got calculated in when I counted the plain pizzas. So the plain pizzas were made up of the large and the small. So I counted those 19 two times. So that's why I have to subtract them out. So I do 49 plus 59 minus 19, and I get 89 out of 131. And 89 out of 131 is 0.6794. So that's the probability that I pick a small or a plain. Okay, so we're going to try H. I'm going to erase this. All right, so this is asking the probability of large or with toppings. So again, I have to think about, is there overlap? And there is overlap. I can have a large with toppings, so I'm going to count that twice. So it's going to be the probability of a large plus the probability of toppings, but I have to subtract out the probability of large with toppings, so where they overlap. So the probability of a large is 82 out of 131, plus the probability of toppings is 72 out of 131, but I have to subtract out the large with toppings that I counted twice. So this 42. So I'm going to do 82 plus 72 minus 42, and I get 112 out of 131, or 0.8550. So that's how we use the addition rule. We have to think about, is there overlap? If there isn't, I just add them up. If there is, I have to subtract out that overlap that I counted twice. All right, good luck.